Hello everyone. In this lesson we're going to take a look at molecules and formulas and introduce the idea of the mole. So first we're going to look at molecular formulas. We've been talking about compounds all year long. A compound is represented by a molecular formula. This is a molecular formula over here. You can see it's got the element symbols, carbon, hydrogen, and oxygen. It's got these little subscripts down here that tell me how much of each one of those is present. So this says 6 carbons, 12 hydrogens, 6 oxygens. It also has this coefficient out front that says 3. So I am talking about 3 of these glucose molecules. Now in total that means I would have 18 carbons, 6 from each of the molecules. So 3 times 6 is 18, 36 hydrogens, and 18 oxygens. These coefficients only multiply the molecule they're with, so later we'll see chemical equations where we have multiple molecules that are reacting. This molecular formula is a representation of a compound, but there's more than one way to represent a compound. These are other formulas. This is a structural formula. It shows the elements in the compound represented as symbols, and then it shows lines that shows how the elements or the atoms are bonded together. Later we'll spend more time on bonds. We'll learn about single, double, triple bonds, but for now, if you see this, this is telling you, look, I have CH4 because I have 1 carbon atom bonded with 4 hydrogen atoms. This is a ball and stick molecule, which gives the same information, except it also includes how they are arranged geometrically in 3 dimensions. So this tells me the shape of the molecule. These are not to scale in this image. In this final image, it's a space-filling compound. It does show the relative sizes of the atoms within the molecule. So those are just 3 other ways of representing a chemical compound. Now, molecular formula tells me the exact number of atoms that are actually bonded to make that particular molecule. However, we can also use empirical formula, which just shows the ratios of the atoms in the compounds, not the actual amount of atoms. And usually this is something that you determine experimentally, like we figure out the ratio of carbon to hydrogen to oxygen in a molecule, and then we figure out the mass of one molecule, and then we use the ratio and the mass to figure out how many of each atom are actually in the molecule. So if I tell you that the molecular formula is C6H12O6, getting the empirical formula is trivial. You just divide it by the least or the greatest common factor of those things. So 6, 12, and 6, their common factor is 6 divided out. I got 1 carbon, 2 hydrogens, 1 oxygen, which does bring up another point. If you see an unsubscripted element, that means there's one of them. We don't write the subscript or the coefficient 1. So the absence of a number indicates the presence of a 1. Now, this next thing is actually probably new for us, and this is the mole. The mole gives us a way to count atoms. A mole is just a number. A dozen is a number. A mole is a number. A dozen means 12. A mole means 6.022 times 10 to the 23rd. Now, why that number? Well, because if we use that number, we can convert back and forth between atoms or particles or molecules and grams really, really easily. So the idea of the mole is to help us count atoms. Since atoms are too small to count individually, we count them by weighing them. And so what we get is the idea of the mole, 6.022, and we usually round it to 6.022. The rest of those decimals are significant, but for this class, 6.022 is sufficient. So 6.022 times 10 to the 23rd particles or atoms or molecules or anything per mole. Now, this leads to the idea of molar mass. Molar mass is the mass of 1 mole of a substance. And the reason 6.022 times 10 to the 23rd was picked is because if I have that many atoms of any element, then I have a mass equal to its atomic mass. So right here, the atomic mass in AMU, atomic mass units, is numerically equivalent to the molar mass in grams per mole. So 1 mole of carbon-12 atoms weighs 12 grams because the molar mass of carbon-12 is 12. 1 mole of chlorine atom weighs 35.45 grams because if we go to the periodic table and look up the molar mass of chlorine, it's 34.45 AMU. Now, why are these two numbers, 12 grams and 34.45 grams, different if they're both talking about a mole? Well, because chlorine atoms weigh more than carbon atoms. Chlorine atom has 17 protons in it. Yeah, 17 protons in it. A carbon atom only has 6. So it makes sense that chlorine has to have a greater mass for the same amount of particles, because each particle itself is bigger. Just like a dozen eggs has a different mass than a dozen watermelons. Now, there's also such thing as formula mass. Formula mass is the molar mass of a molecule, which is given by its molecular formula. So to do that, you just have to add up the individual masses of everything in there. That doesn't mean H2O we're going to add hydrogen and oxygen. It means we're going to add 2 hydrogens to oxygen, because there are 2 hydrogens in the molecule. So the formula mass is given by adding up the molar masses of all the atoms in the compound. So this shows that calculation. We take 2 times the molar mass of hydrogen, because there's 2 hydrogen atoms, plus the molar mass of oxygen, because there's only one of those, and we get 18.015 grams per mole, which means if we want 1 mole of water molecules, we would need to measure out 18.015 grams of it. And if we had 18.015 grams of water molecules, we would have 1 mole, which means we would have 6.022 times 10 to the 23rd molecules of water.